Technology uncertainty is one of the most important dimensions for differentiating among projects. Technology uncertainty is the extent to which we do not know whether technology will work or will not work as expected. Assessing technology uncertainty can be tricky, even in low-tech industries, such as in construction. I start explaining technology uncertainty with an example. The case of the construction of the Denver International Airport is a classical case study of technology uncertainty. It was expected in this case to be a standard large construction project of a large airport, of course. However, it became a nightmare for all its stakeholders. United Airlines required an automated baggage system. They wanted a state-of-the-art integrated system. This project, the baggage handling system, was the first of its kind and bigger than anything else has been done before. From the beginning, there were many problems. There was lack of communication, unrealistic time frames, insufficient planning, and misuse of human resources. By August 1994, the project was 11 months late and put at risk the actual airport operation. To avoid additional consequences, stakeholders thought in a plan B. They decided to build an additional conventional baggage handling system for $50 million. At the end, the airport opened for business in 1995, 16 months late and 1.5 billion over budget. The reason is that they put insufficient attention to project uncertainty. Although the airport construction is a low-tech project, the baggage handling system had many elements of a high-tech project that required several design cycles and extensive testing. Project managers fail to fully understand the risks and the need to decouple the baggage handling system from the airport construction. The baggage handling system was the first of its kind. BAE Systems, the company who was manufacturing the baggage handling system, was familiar with building automatic baggage handling systems, but in a smaller scale. Many components of the technology were new. There was a high degree of technological uncertainty and the time frame was short. In retrospect, upfront understanding of the technological uncertainty involved in the project would have enabled managers to consider a backup system from the very beginning. Technology uncertainty indicates how much new versus mature technology exists in the project. The project's technology uncertainty level is not universal, but it is subjective, that is, it is relative. It depends on the technological know-how that exists and is accessible to the organization. In summary, technology uncertainty is the extent to which technology is new to the company. This means that the level of technology uncertainty will change from company to company. A project that may be assessed as has high technology uncertainty in one project can be a medium level of technology uncertainty in other project in another company, because the second company or project do have access or experience with the technology that is being used. There are four levels of technology uncertainty. Low-tech projects rely on existing technology, well-known technologies. Medium technology projects use existing technology and few elements of new technologies. High-tech projects represent situations in which most of the technologies that are used are new to the firm but already exist in the world. So they are available in somewhere. And super high-tech projects are different. They are based on new technologies that do not exist at the beginning of the project. While the goal of the project may be clear, the solution and the technologies to be used in order to achieve that goal will be developed during the project. This is an example of a low-tech project that uses well-known existing technologies. Technologies being used here are mature technologies that all players have equal access. In low-tech projects, therefore, the uncertainty in the execution of activities is low and there are few difficulties, and any difficulty is a difficulty that it is expected. However, also they offer little potential competitive advantage because any other player can do exactly the same job. Projects that have medium level of technological uncertainty are common in industrial projects. They use mature technology and only a limited amount of new technologies. For example, they can incorporate a new feature of existing technology that not has been tried before in the new model of the automobile. This slide contains the concept of medium level technology uncertainty. Please read it on your own time. High-tech projects constitute the first use of new but existing technology. Technology have probably been developed before the actual project, but they are not embedded or integrated into a product, process, or project. On this slide, you can see the actual baggage handling system that was manufactured by Siemens and installed at the Shanghai International Airport. This is an example of a software that drives the mechanical part of the baggage handling system. If this software is new to the company, I mean, is the first time that they are using to drive the mechanical part of this baggage handling system, it can be considered a high-tech project. However, if it is the same software that they have used in the past in very similar baggage handling systems, maybe it is not considered a high-tech project. And that is the point. The level of technological uncertainty is a relative to the company and to the project. So, high-tech projects constitute, as I mentioned before, the first use of new but existing technology. And those technologies has not yet been embedded in actual products or processes, such as in the case of being embedded in the airport system, in the case of the baggage handling system. What it is interesting that when we use existing technologies that are new, this may lead to new products or new industries that didn't exist in the past. Can you think in a product that use existing technologies that but lead to the emergence of a new product or a new industry? We can discuss this during the workshops. Super high-tech projects require the development of new technologies that do not exist at the beginning of the project. Usually these projects are developed by large organizations or government agencies, since they are long-term and require multi-billion-dollar investment. Here on the screen you can see one example of a super high-tech project. Virgin Aerospace is developing a project to manufacture this aircraft that will allow us to go from Brisbane to London in 5 hours. Of course, at the beginning of the project, and still probably they have not developed all the technologies that they need in order to manufacture the aircraft. But this is the nature of super high-tech projects. The technology is developed during the development of the project. This, of course, brings significant challenges to the management of the project. Here we have another current example of a super high-tech project, the development of the Hyperloop. The Hyperloop is a machine that will transport people by surface at a speed higher than a Boeing 737. And in this screen, you can see the general idea, the concept of the Hyperloop. The important point here is that several of the technologies they are trying in order to achieve this goal are still under development. Some of the technologies still do not exist, and but they are creating a totally new product and maybe a totally new industry. In this slide, we have some additional details regarding the concept of super high-tech projects. Please read it on your own time. In summary, the level of technological uncertainty depends on the specific technology base of the firm and the industry that is developing the project. For example, in a low-tech firm developing a new type of product that uses some new technologies, this project can be considered a high-tech project. But the same project can be seen as a medium technology project in a more technology-savvy firm. Technology uncertainty, of course, is related to risks. The risk of failure increases with each level of technology uncertainty. Importantly, technology uncertainty affects how do we manage a project. Different levels of technology uncertainty impact project management activities not only regarding technical specifications and product configuration, but also levels of communication, interaction, and the actual management of the project. For example, in this slide, you can see that the more technology uncertainty, the more design, development, and testing activities become critical and necessary. In low-tech projects, no development or no testing is needed. Usually just one design cycle is enough, because the technology is very well known, of course. Now, on the other hand, in high-tech projects, more testing is needed. More number of prototypes are necessary in order to test the solutions that we are looking for. So 2 or 3 design cycles are at least necessary in high-tech projects. In super high-tech projects, successful projects even build small-scale prototypes to test new technologies before the final selections of the technology. The higher the technology uncertainty, the higher the number of design cycles, as you can see in the slide. The higher the level of technology uncertainty, also the later you should freeze your design point. And finally, the more technology uncertainty, the more time is necessary to spend reviewing technical issues of the project. We also can see in this slide that the management style needs to be or can be more firm and stable and hierarchical in low and medium technology projects. But in high and super high technology projects, the management style needs to be flexible because it is expected that there will be many changes and managers need to build those expectations and they need to know how to live with continuous changes. This means that interaction and communication in low tech and medium tech projects is mostly formal. It's frequent but formal. Now, interactions and communication in high tech and super high tech projects need to be not only formal and informal, but through multiple channels because it is necessary a close connection between many different partners in the projects to be successful. In a similar way, the project managers need to have higher and higher administrative skills and expertise, the higher the technology uncertainty associated to the project. That is, managers not only need to have administration and management skills, but also a combination with technical skills and people skills in the case of high-tech and super high projects, because they need to know how to communicate with totally different partners. The contingent resources also, of course, are related to the level of technological uncertainty. As you can see here in this slide, low and tech low and medium tech projects need between 5 and 10% of contingent resources. However, the level of contingent resources will increase in significant extent in high and super high projects, especially in super high projects that could be 50% or even more, because there is a lot of uncertainty related to whether or not the technology will be working and how long time it will take to develop new technologies that are suitable for our project. Technology uncertainty also affects the managerial style used in order to develop the project. Because of greater technology uncertainty, there's a need to delay design freeze and conduct more design cycles and testing. This requires a more flexible management style and tolerance for ambiguity. This means, as you can see in this slide, that there are major differences between low and high-tech projects in the management approach to be used. In low-tech projects, it is possible to follow a plan because we know the specifications, the aims of the project, and the goals and resources are very stable. It is expected that there will be few problems. Conversely, in high-tech projects, because there is high level of technology uncertainty, management style need to be more flexible. It is necessary to expect many changes in specifications, many changes in availability of resources, or simply many changes of mind from key stakeholders. A major issue that you can see also in this slide is related to the type of contract to be used in projects. In low and medium tech projects, we can use fixed price contracts in which contractors takes all the risks but also have the chance of great profits. In high-tech projects, we usually use cost plus incentive contracts in which the risks and opportunities are shared by both parties. Customers assume the cost of development of the project, avoiding in this way shortcuts in the design of the projects, and contractors have an incentive to produce their best results for the outcome of the project. The Apollo program is a typical example of super high-tech project. As we all know, in 1960s, John F. Kennedy set the goal of putting a person on the moon. Too many unknowns there were in this project. Of course, NASA engineers needed to deal with radiation, with lunar dust, with extreme temperatures, because at that time there was no available technology to protect astronauts from extreme temperatures that happen between shadow and sun areas in the moon. There were also no clear concept of how to launch a rocket from the moon. So the Apollo program adopted a unique development testing approach. Everything was tested more than once. For example, NASA launched 10 Apollo flights before sending a person to the moon. Before sending a person to the moon, they also sent the Gemini capsule to orbit the moon as a small scale prototype. What they were doing was that they were testing how the technology will work. We need to remember that before that, nobody was on the other side of the moon. So they were unaware of how the technology will work when they were on the other side of the moon. So if we think on the Apollo project in terms of the diamond model, we can see that the Apollo program falls within the super high-tech uncertainty projects because when they started the project, technology did not exist. They developed the technology during the development of the project, and was part of the project. And of course, as I mentioned before, a significant aspect was that they had to do many design cycles. They had to construct many prototypes in order to know whether or not the technology will work. At the same time, we can see that in terms of novelty, the Apollo program falls within the breakthrough project because it was something that it has nobody seen before. It was a new product, totally new product. If you have any question, any inquiry regarding the concepts of technology uncertainty, please write it down and we will discuss your inquiries in the workshops and on in the collaborate sessions. At this point, you need to apply the concept of technology uncertainty to the iPod case. We will discuss this case during the workshops and during the Q&A online collaborate sessions. Please try to answer these two questions, and in order to do this, please use the concepts of and definitions of technological uncertainty that has been presented in this course. In this case, you also need to map the level of novelty and technological uncertainty associated to this project and discuss especially the management implications of your solution achieved.